All right, real quickly, wanted to give you a little bit of help. Today we talked about slope and the equation of line going through a point, which is a little different than them giving you 2 points or giving you the equation right out of the bat. So let's look real quickly at a number, an example from the book. Here's telling me the slope is a -3, and it goes through the point. What do they got here? 1, -4. So here's my formula I'm going to use. Y minus y1 equals m times x minus x1. And to trigger these through, here is y1 maps to this one. X1 goes to here, and m goes to here. So it's just a system of plugging and chugging. So I go y minus -4, keep it in parentheses because you get that minus negative, equals m, which is the slope, times x minus 1. And from here I'm taking the distributive property, multiplying those through. Y minus -4 gives me y plus 4 equals distributive property, -3x plus 3, because -3 times -1 is a +3. Get rid of the 4 because I got to put it in point slope form. -4, so I end with y equals -3x minus 1. There's the solution to that problem right there. Quick, here we go. Slope equals 1/2. The point is 2, 3. So again, same issue, or same formula, y minus y1 equals m times x minus x1. Plug and chug, y minus 3 equals the slope times x minus 2. Distributive property, y minus 3 equals 1/2 x minus 1/2 times 2. I'll do it over here. 1/2 times 2 is the same as 2 over 1. You multiply straight across. I get 2 over 2, which equals 1. Add 3, y equals 1/2 x. -1 plus 3 is going to be +2. 2 down. I basically said instead of giving you the slope and a point, they gave you 2 points. So as I look at this, let's say I was doing 1, 0 and 5, 5. Well, before they gave us a point and a slope, and now they're giving us 2 points. But I know from a previous section that I can get slope from 2 points by subtracting the y's over the x's. So this translates to 5 minus 0, 2 y's. If I use my pointer here, this one's for you, Deshaun. 5 minus 0, and then I'll take my x's, take this 5, and subtract 1. So I get 5 minus 1. So 5 minus 0 is 5. 5 minus 1 is 4. So now I have my slope, and I have either one of these 2 points that I can use. So here's my other equation, y minus y1. Sound familiar? M times x minus x1. Plug and chug. Here's my slope, m equals 5/4. So I have y minus, I can use either one of these points. Let's see what happens if I use this one right here. I'm going to say y minus 0. That should be interesting. 5/4 times x minus 1. Well, y minus 0 is still y. Distributive property. 5/4 x minus 5/4. And you'll find that equation right there is exactly what you need, that you can graph that from here if you want. Let me do one more. So let's try some big numbers. Let's go. We got 7, 11, and 13, 17. Looking for slope, so I'm going to go 17 minus 11 over 13 minus 7 gives me 4 over, oh, not 5. What am I thinking? 13 minus 7 is 6, which equals 2/3. I'm going to reduce that fraction. There's my slope, 2/3. I'm actually, let me do this one right here, 7/11. So y minus 11 equals 2/3 times x minus 7. This is going to be gross. Y minus 11 equals distributive property, 2/3 x minus 14/3. So I got to add 11 to both sides. We'll do a new slide here. So I got y minus, we'll just repeat from what I got here. Oh, let me go back. 2/3 x minus 14/3. So I am going to add 11 to both sides. 2/3 x. So now all I got to do is mess around with some fractions. 14/3 is roughly 4 2/3, or 4.66. And I've got to add 11 to this. So I got y equals 2/3 x. Actually, that's a negative, so I'm going to take, so that's going to be 6.33 plus 6.33. You can use your calculator to get through that mess right there. There you go.